To get started, try evaluating the following expression, 3 times 4 squared. Or click down here to review squaring numbers or how to evaluate expressions with parentheses. Right, first you multiply 3 and 4 to get 12, and squaring 12 gives you 144. So this expression equals 144. Let's see if we can figure this out another way. Squaring 3 times 4 means we're multiplying 3 times 4 by another 3 times 4. And remember that when you multiply numbers together, you can do it in any order. So let's swap the places of these two middle numbers. That gives us 3 times 3, or 3 squared, times 4 times 4, or 4 squared. So it looks like 3 times 4 squared equals 3 squared times 4 squared. Try evaluating this expression to make sure that's right. Exactly. 3 squared is 9, and 4 squared is 16. And 9 times 16 equals 144. So 3 squared times 4 squared equals 144, and these two expressions really are equal. So we've stumbled across a rule that always works. You can distribute exponents, like this 2, onto numbers that are being multiplied. So we can distribute this 2 onto the 3 and the 4, giving us 3 squared times 4 squared. Try applying this rule to another example. Which of the expressions down here is equal to 5 times 7 raised to the 8th power? Right, distributing the 8 onto the 5 and the 7 tells you that this equals 5 to the 8th times 7 to the 8th. Suppose now that you start with 6 to the 4th and you're multiplying that by 5 to the 4th. This actually equals another number raised to the 4th power. Try using this rule to figure out what this missing number must be. Excellent. So this missing number must be 6 times 5. And 6 times 5 equals 30. So 6 to the 4th times 5 to the 4th equals 30 to the 4th. So you can distribute exponents when you're multiplying numbers. What about division? So let's say you have 2 divided by 3, also known as the fraction 2/3, and you're raising it to the 4th power. So that's 2/3 times 2/3 times 2/3 times 2/3. If you multiply these fractions together, what fraction do you get? Enter the numerator and denominator of the product over here, or click down here to review multiplying fractions. Precisely, this equals 16 over 81. To get 16, you raised 2 to the 4th power, and to get 81, you raised 3 to the 4th power. So it looks like distribution worked for this example. Whenever you divide numbers and then raise that to a power, you can distribute the power and then divide. In other words, distributing exponents works for both multiplication and division. So try another example. 10 to the 7th divided by 2 to the 7th equals another number raised to the 7th power. What's the missing number? Nicely done. So this equals 10 divided by 2, then raised to the 7th. And 10 divided by 2 equals 5. So 10 to the 7th divided by 2 to the 7th equals 5 to the 7th. So great, you can distribute exponents when multiplying or dividing. But what about addition and subtraction? Well, let's find out. Say you have 3 plus 4 squared. Can you distribute the square onto the 3 and the 4? So does this equal 3 squared plus 4 squared? To find out, try carefully evaluating these two expressions, and let's see if they give you the same answer. Right, 3 plus 4 is 7, and squaring 7 gives you 49. Meanwhile, down here, adding 3 squared, or 9, to 4 squared, or 16, gives you 25. So these two expressions are not equal. What does that mean? That means whenever you're adding numbers together and then raising to a power, you cannot distribute the power. It will give you the wrong answer. And the same goes for subtraction. So to summarize, you can always distribute exponents onto numbers being multiplied or divided, but never onto numbers being added or subtracted.